Hey everyone, and welcome to The Explainer. Today we are stepping out of the era of basic, traditional AI, and we're crossing the threshold into the age of truly autonomous, decision-making systems. It is a massive paradigm shift that's completely reshaping technology as we know it. We're going to dive specifically into how this shift is fundamentally changing the way we secure our digital enterprises. Let's get into it.
So think about this for a second. A little philosophical hook to start us off. Is a highly complex computation the exact same thing as consciousness? I mean, a calculator provides a perfect solution to an arithmetic problem, right? And a massive GPU can deterministically crunch petabytes of data without even breaking a sweat. But neither of those things exhibits self-awareness or true agency. As our source material points out, even a random lightning strike hitting hardware and producing transient states doesn't magically create consciousness. It's so vital to remember that just processing data is not the same thing as having the self-referential, structured awareness you need to actually make independent choices.
All right, here's our roadmap for today. We'll start by looking beyond basic computation, then track the rise of agentic AI and explore proactive AI and security. After that, we'll pop the hood on the architecture of autonomy, discuss building essential guardrails, and wrap up with a fascinating dynamic, the master and servant. I promise by the end of this, you'll know exactly how these machines are evolving into proactive agents and, crucially, how we can keep them aligned with our goals.
So let's kick things off with Section 1, Beyond Basic Computation. Let's define what traditional AI actually is.
Look, the bottom line here is that processing data just does not equal conscious awareness. Traditional systems, think of highly complex databases doing pattern recognition or intricate decision trees optimizing a task. They follow very strict predefined programming. Are they incredibly capable tools? Absolutely, but they completely lack the self-referential awareness needed for true autonomy. They rely entirely on mechanical operations dictated by their code and the data you feed them. They don't choose, they just execute.
Which brings us to Section 2, the rise of agentic AI. And honestly, this is a massive paradigm shift.
Let's make sure we clearly define this term because it's the core of everything we're talking about. Agentic AI refers to artificially intelligent systems that autonomously perceive their environments, make decisions, and take actions to achieve their objectives. Notice the emphasis on the word autonomously. These systems fundamentally shift the role of the human. We're no longer the constant, in-the-weeds monitor tweaking every single step. Instead, we become more like a high-level manager. We supply the overarching directives, and the agent AI, it just handles the real-time decisions and execution all on its own.
But of course, it's a crazy balancing act we find ourselves in now. On one hand, you have the potential for massive public and private sector gains, incredible efficiency, and advanced accountability. But on the flip side, you have these very real existential risks. We're talking about the danger of uncontrolled systems, misaligned goals, and even runaway processes if these agents are deployed in high-stakes environments, like battlefield AI, for example. Delegating high-level responsibility to a machine means we absolutely must demand robust, distributed alignment to keep things safe.
So how does this actually apply to the real world? Let's move to Section 3, Proactive AI and Security, where we get into predictive defense.
Think about how distinct these two eras of security really are. Traditional security is fundamentally reactive. It relies on known signatures. That basically means it only catches what it already knows is bad. And what happens? You end up with massive, overwhelming alert fatigue for human analysts. But generative AI security, it's flipped the script entirely. It's proactive. It acts as an agent, using advanced behavioral analysis to predict and identify zero-day threats. It's not sitting around waiting for a known signature to trigger an alarm. It's anticipating the attack before it even happens. The hard data backing this up is actually pretty wild. When you measure the effectiveness of generative AI techniques in threat detection, particularly for novel threats, techniques like generative adversarial networks, or GANs, drastically boost detection rates. We're talking about hitting an incredible 87% for zero-day threat identification. By setting up this dynamic where a generator tries to create sneaky, evasive attacks and a discriminator learns how to catch them, the AI essentially trains itself to spot the abnormal. It anticipates attackers with shocking accuracy.
Let's look under the hood in Section 4, the architecture of autonomy. How exactly do these agents operate?
You can really break this architecture down into three core steps. First up is perception and world modeling. The agent is constantly pulling in information from its environment, combining sensory input with external knowledge to build this continuously updated internal model of the world. Step 2 is goal formulation. Based on whatever abstract responsibilities we've given it, the agent formulates an internal goal, a desired state of the world it wants to achieve. And finally, step 3 is evaluation and adaptation. The agent connects its goals to actual actions using non-ideal but highly effective heuristics. It tests its plans, verifies them against the environment, and constantly adapts based on the feedback it gets.
And just to ground this in reality, check out some of these real-world wins. In the finance sector, bringing in these AI agents led to a massive 87% reduction in false positives, plus a 62% faster detection time for sophisticated attacks. That's huge. In healthcare, they saw a 76% reduction in unauthorized access and proactively discovered 23 hidden vulnerabilities, literally just by having the AI simulate complex attack paths on its own. This proves this architecture isn't just theory on a whiteboard. It is actively, significantly optimizing security team efficiency today.
But with all that capability, we absolutely need Section 5, building essential guardrails, controlling the agents. We need massive technical frameworks to safely govern these things. The essential guardrails really break down into 3 main pillars. First is accountability and responsibility, meaning we always have a clear, human-authorized user who ultimately delegated the task. Second is transparency and explainability. We absolutely must use explainable AI techniques, like shot values, for instance, so that when an agent makes a crucial security decision, a human analyst can audit the black box and understand exactly why it made that choice. And finally, regulatory compliance. We have to ensure these systems meet strict data privacy and auditability standards. The whole shebang revolves around a human-in-the-loop design.
Which brings us to our final section, Section 6, the master and servant. Let's look at this evolving relationship between humans and AI.
When you start assessing societal impact and safety constraints, you realize that metrics like bias and unfairness control, which score incredibly high in priority, along with explainability, are paramount. When we delegate high-stakes tasks to autonomous systems, we are literally trusting them with our digital and sometimes even our physical lives. Keeping them unbiased, transparent, and responsibly steered is the only way we prevent catastrophic failures.
I want to leave you with this thought-provoking analogy straight from our sources. It says, society's relationship with machines increasingly resembles that of masters and servants. The challenge is ensuring that these increasingly self-willed servants remain sympathetic to their master's interests. As these AI agents become more and more autonomous, they are going to perceive the higher-order consequences of their decisions way better than we ever could. So the real question is, how will we successfully maintain alignment and ensure our human values remain intact as our AI servants grow ever more capable? It is a fascinating challenge and, honestly, one we have to solve. Thanks for joining me on this explainer today.